Okay guys, next topic is field intensity on an axial line of electrical dipole field. So you know already dipole setup minus q and plus q in between the distance between them 2a. Now I wanted to calculate the I wanted to calculate the electric field, means a dipole field. I wanted to calculate dipole field intensity. If I bring in this setup any charge, definitely there will be a attraction and repulsion force simultaneously it will act. So if I take a positive charge on the same line of action, if I take a positive charge, now due to this particular charge, now due to this positive and positive, it will repel. So force action will be in this direction. So I have already starting only I have taken the forces here. Force of this one is F2, force due to this charge, positive charge is F2. Electric field intensity is E2. Here is for minus Q1, force of this one is F1. Electric field intensity is E1. Now you due to this particular charge, this will repel. So force of action will be in this direction. And you know already force is in this direction, then electric field intensity also in this direction only. Here also due to this particular charge, negative charge, this is positive charge, it will attract. So it will attract, then the force of action will be here, and electric field intensity is also same direction like a force of action F1. So from there I am wanted to study, let's take this is a point, at a point it is at a B point. So now take at a A point. A point means a positive charge. Due to this positive charge, what is the electrostatic force felt by this particular test charge? So which is Q naught divided by R. Now the distance is what is there from the dipole center. This is from dipole center to this test charge is exactly located at a R distance. So now this R, now you see this is not exactly equal to R. It is somewhat different only, somewhat less only. So that is why R minus A. So R minus A whole square is the distance between these two charges. Now electric field intensity E2 is equal to what can I write here? F2 divided by Q naught can I write? Then I can write a 4 pi epsilon naught Q divided by R minus A whole square. In every dipole you should take their magnitude must be equal. This positive charge, either you can take any 1 coulomb. Sometimes they have in Pradeeps and all, they gave 1 coulomb. I will take my always I'll represent one test charge with a Q naught. Okay. Now you have electrical intensity E2 is equal to what can I write? 1 divided by 4 pi epsilon naught Q divided by R minus A whole square. So this is a equation 1. Similar way at point A. At point A, what is at point A? This one. Force felt is what will be the force F1. Charges, you know these charges. So here force due to the, according to the Coulomb's law, I can write F1 is equal to what can I write? F1 is equal to 1 divided by 4 by epsilon naught. Charge here Q and test charge is Q naught, and the distance between this is A and R. So R plus A whole square. So now electric field intensity is here. Electric field intensity is here, which is E1. I have so E1 for this one is E1. So which I can write F1 divided by Q naught, which I can write 1 divided by 4 pi epsilon naught into Q divided by R plus A whole square. So this is your equation 2. So one more point I have to come. You see here this charge is very near to the test charge. So definitely the force on this one will be felt more, and electric field intensity also more due to this particular charge. That is why I am writing one certain thing. E2 is magnitude of E2 is greater than the magnitude of E1. So now net charge I am taking net charge is equal to what can I take? Net charge is E. Which one is greater here? E2 is greater. So magnitude of E2 must be greater than the magnitude of E1. Why? Because E2 is very near to this test charge, E1 is little less, so that is why I am taking the net charge E2 minus E1. This is a vector. Why we are taking this one, you know already. This is, it is because it's simple. You can also take according to the direction also. E2 is acting in this direction, okay. E1 is acting in the negative direction. Vector, so if I wanted to add up the two electrical intensity, I should take the vector addition. So vector addition is this one. So E2 is acting in a positive direction, E1 is acting in a negative direction, so I can take this one. So in the next step, now you see here in the next step, so if you want the notes, you have to fuse the video and take the notes. And from here, so this is your setup 3. So in equation 3, if I substitute equation 3, if equation 1 and 2 is substituted in equation 3. So what is the equation 3? This one. Equation 3, I am again, this is a net charge, which is E2 magnitude minus E1. So you have to substitute E2 value. What is the E2 value? E2 value is this one. So 1 divided by 4 pi epsilon naught Q divided by R minus A whole square minus 1 divided by 4 pi epsilon naught 1 divided by 4 pi epsilon naught 1 divided by 4 pi epsilon naught Q divided by R minus A. So here R plus A whole square. Okay. Now, so net charge is equal to, you have a common is here 1 divided in both the terms, 4 divided by epsilon naught is common. So remaining thing is what? 1 divided by R minus A whole square. Here 1 divided by R plus A whole square. So now where is I am going to use a formula. One more step you can write. If I take LCM of it, R epsilon naught, one step I am writing. So LCM, if I take R plus A whole square crisscross minus R minus A whole square divided by R minus A whole square R plus A whole square. So I will take one formula, that is A plus B whole square minus A minus B whole square is equal to, what can I write? 4AB. So this is same format. Again one more formula I can write, A minus B whole square into A plus B whole square, which I can write A square minus B square whole square. So these two formulas I am going to utilize here. So directly I can write now, the net charge would become what here? Q divided by 4 pi epsilon naught. This is a basic. From this one I can write 4 into A means 4A RA, here R square A minus R square A square whole square you can write. Okay. So next one more here. This is axial electric. This is a net charge. There is a net charge of what? Axial line. Net electric field on axial line. So E is equal to, what can I write? Q into, so one simple thing I am separating here. Q into, from this 4A I am going to write 2A separately divided by 4 pi epsilon naught. Remaining will be what here? 2 into R. Okay. Divided by R square minus A square whole square. Okay. Now you know what is a dipole moment. Dipole moment I already discussed. P is equal to, what can I write? Q into 2A. So instead of P, what can I write here? You can write, instead of Q into 2A, you can substitute this one. So E is equal to, what I'll get here? So you will get a P into 2R divided by 4 pi epsilon naught into R square A square whole square. So this is a vector, this is also a vector. So P bar is the direction of dipole moment, which is negative to positive. So we'll continue this thing again in the next page. So let's suppose, so I have already, this is a equation. you can take this is the equation, required equation, which is equation 3. Equation 4 you can mention. In equation 4, if distance, let's suppose that I have taken this positive charge here, positive charge is comparable to this, the distance between this dipole. If the charge is very far, then r is, if r is very far, then what can I take here? So distance is greater, then what can I, if r is very greater than the distance between the dipole, I can, then what happens here, I'm going to neglect. So then what happens here, r square minus a square is similar to r square only. Why? Because it's very comparable to r square. Compared to r square, a square is very small, so it is almost equal to r square I am taking. So this is I am going to replace in fourth equation. So fourth equation, E, the net axial net electric field, then what happens here, p bar by 4 pi epsilon naught into 2r divided by, instead of r square a square, I can replace with the only r square, then r square whole square. Now you know already, p bar 4 pi epsilon naught 2r divided by r square and whole square, in r power 4 it will be there, r cancelled, r cube will be remain. So electrical field, it's a vector quantity, p bar divided by 4 pi epsilon naught, now 2 divided by r cube. This is a net charge. This is nothing but your electric field intensity due to dipole on axial line. So we also represent this for our convenience. Electric field intensity due to dipole, E axial, is equal to, what can I write, p bar divided by 4 pi epsilon naught and 2 divided by r square. This is our required equation. Again, here from this equation I am going to analyze few things here. What is the analyzation I can do here? Analyzation you can do here, once you can do here, that is r cube. This is r cube. Analyzation is electric field intensity is inversely proportional to r cube. Why? Because you see, this is important point. Why you generally, in general electric field intensity is directly inversely proportional to r square, but in dipole it is 1 by r cube. Means in dipole, this is a dipole setup. If I take a negative and positive q, so in dipole setup, if I take a point, if it is away from the this dipole, as a point as distance increases, this r positive charge distance increases, then the field of this electric field intensity will be reduces rapidly in the dipole. So dipole field will be reducing rapidly, but in general this is what is directly proportional to r square. In general electric field will be like this, but in dipole field it will be is inversely proportional to r cube. This point is very important. Second one, you see here the direction of here E axial is the direction of electric field intensity is axial, is the same as what here, this one, dipole moment. So these 2 points are very important for the objectives. We'll discuss the next topic.